Many adhesives that we use typically are pretty simple to apply, like the white glue. We can just apply it with a brush and clamp the assembly together, and then it will cure in a period of about 45 minutes or so. Other glues for special purposes, like gluing glass together, for example, require very specific types of equipment. This glue is an ultraviolet glue which cures via ultraviolet light. So if you've been to the dentist recently and had a filling, you've probably had a UV curing filling put in place, and then they shine an ultraviolet light in your mouth, and that cures the resin to form a really hard, durable surface. This adhesive is available in the Glass Studio, and it requires special precautions for use. And we'll see on the sheet here that it requires glasses and gloves used in a well-ventilated area. This particular adhesive doesn't cure by evaporation or absorption into the material, because the material is a non-porous material, glass. It requires the use of a special light which activates the glue and cures it. And this is an ultraviolet light bulb. It's very hard to see whether it's light or not in there. When we lean it down against the bench, you can see the color there. And it has an ultraviolet light mounted inside a reflector. There's a bit of preparation that I want to do before I start using the UV curing glue or the ultraviolet curing glue. I'm going to put a piece of white paper down so that when I turn on the light will be reflected back up into my glued assembly. Ultraviolet glue, because it cures with the ultraviolet light, requires a transparency or an ability for the material to admit the ultraviolet light through the assembly in order to cure it. So we can't use ultraviolet glue to, say, cure two pieces of metal that are sandwiched together because the light can't get through them. And however, glue metal to glass because the light will transmit through the glass and cure the ultraviolet glue from above or below. So here I've glued a T-nut to a piece of glass, and that will allow me to bolt an assembly onto the glass. I'm going to put a pair of sticks down which will raise my assembly up off the surface, so when the glue goes on it, it's got something to drip down onto. And I'll take one piece of glass and I want to glue another piece of glass directly to that. I'm just going to glue it 90 degrees to itself like that. If you're laminating glass, you might stack them up so that we have a double layer there to build up thickness. The nice thing about ultraviolet curing glue is it's clear, so if it's applied correctly, you'll end up with a completely transparent bond. There's a possibility of air bubbles entrapped in the surface, so that's an issue to be aware of. And you also want to make sure that your surfaces are perfectly clean. I'm also going to put a pair of blocks of wood on either side of the assembly that are spaced far apart enough that I can rest the ultraviolet curing device on top, and when I turn on the light, that puts the light into the assembly, and it'll bounce off the white card as well and allow it to cure a little faster. It's a good idea to have some paper towel on hand just in case of spills, and I'm going to take the glue and put a small quantity of glue on that surface. It doesn't really take much. It's going to be a very thin layer of glue. I'm going to close this off, and we've got a fair amount of setup time here. I'm going to move that around, pressing down on the surface and allowing it to apply the glue to the entire surface. And if Jason were watching me now, he'd probably say, "No, you don't do it that way." Okay, well, anyway, we'll give it a try. So that has created an assembly now where there is very little air bubbles there. I'll try moving that around a little further just to ensure that I've got a complete coverage of the adhesive all over the surface. You can see how easy it is to move that around because the glue is essentially acting as a lubricant at this point. Once I'm satisfied that I've got a good thin film of glue and there are no air bubbles in there, I'm going to align the pieces together as best I can. The glue will not cure without ultraviolet light. There's a little bit of ultraviolet light coming in here now from daylight and so on. But you've got a fair amount of time to get your assembly set up correctly. If you need to, you might have some blocks on either side that just to make sure that things don't shift on you. And I'm putting my riser blocks on either side of my assembly, putting the ultraviolet light on top of it. I'll turn it on and I'll leave that for 5 minutes and we'll come back and see how it looks. If you're going to apply metal to the glass, as I did with this little assembly right here, you're going to need to clean the metal first. So I've just taken some sandpaper and I'm just sanding that lightly to ensure that there's no burrs on the metal to make sure it's perfectly flat, and clean of any rust or oxide. So that'll allow me a nice clean surface to attach to the glass. I'm just going to set the ultraviolet light aside for a second and put a drop of UV glue on the glass. Again, very small quantity, and I'm just going to set that piece of metal. It's a threaded insert called a T-nut, which you will remember from your fasteners lecture. And I'm going to put this back in place and let that cure. So I've left this light on for about 10 minutes on our assembly, so I'm going to turn the light off and we'll see how it has cured. Let's move those blocks away. Glass is not shifting, and that little metal stud, the T-nut, is adhered quite securely, and it's nice and clear. So it's obviously done its job, and that's how you glue glass together with a UV curing glue and the UV light. Another highly specialized type of adhesive that we use is a solvent weld adhesive for acrylic. And acrylic is a resin, obviously, and it's most often seen as an extruded sheet of various thicknesses. And this acrylic material can be bonded together typically by welding the seams together with an adhesive that melts the acrylic. The acrylic sheet edges, I'm going to be bonding them together in an assembly here, and we can just see from the side here I've made up some little clamping jigs to be able to hold it at a perfect 90-degree orientation, and so that the edges of the sheet are perfectly flush with each other when they're clamped together. So it takes a little bit of effort to make up a clamping jig, but that will allow us to position everything in exactly the orientation we want. The adhesive is a very thin, low viscosity liquid, almost like water. And it's methylene chloride, which is a chromosome disruptor and a carcinogen. So it's a very toxic material that you want to wear, obviously, gloves, use it in a well-ventilated area, and have glasses on when you're applying it. The way that adhesive works is by effectively wetting out the surface of the acrylic joint, and it melts the acrylic on the joint into the other part that you're joining it together. So this will only work between two similar types of plastics. So it will bond acrylic, polystyrene, and polycarbonate. And it's typically applied with a little syringe-like tool. It's a squeeze bottle that has a very fine, hollow syringe applicator. There's a number of ways of applying the adhesive, but they all rely on a perfectly flat milled seam that joins together. So I can join the two sheets edge to edge, on side edge to the side, which is the way I'm joining it there. We can see here, I don't know if it's visible in the camera, but the surface quality of the edge there is just cut with a saw, so that's not really accurate enough to join together and create a nice clean joint. The edge typically is either routed on the router table or passed over the jointer to machine a perfectly flat surface that also is free of chips or saw marks. And that will mean that when I apply the acrylic adhesive, it will wick into the joint through capillary action, wet out the joint, and solvent weld the two together. And so right now we can see that there's a sort of a white reflective surface there that you can see the edge of the acrylic. If it's a good acrylic joint, the glue will wick into that and make it completely clear and transparent. When I apply the solvent weld or the adhesive to the joint, I'm going to feed it in from behind and simply apply the adhesive or the nozzle just into the inside corner and draw it along as I squeeze the adhesive out. And you can see it starting to wick in there. I'm going to go from both sides and squeeze that in. It will absorb into the joint and it will become completely clear as I do it. You can see a little bit of area there where the glue has not wicked in fully yet. I'm just going to run a bead along the edge of the joint here just to ensure that it absorbs all the way in. And now the joint has become completely transparent, and I'll just let that sit for about 10 minutes undisturbed until the joint has cured. Alternate ways of achieving the same thing is by dipping the acrylic into a shallow pan of the solvent and then setting it in place. After about 5 minutes, I can take all the clamps off, and the joint is finished. It's stable and should be reasonably clear in the corner, and that will be theoretically as strong as the acrylic on either side of the joint, because what we've done is essentially melted the one piece of acrylic into the other one and created a clean seam. So obviously it's really important that that material be perfectly machined rather than a rough sawn, table sawn surface like we have on this edge here. And that's how we solvent weld acrylic.